Hi and welcome to the fourth video on calculus, on derivatives. For this video we'll be looking at just some basic derivatives. Now most of this sort of thing you've seen last year. The only difference I guess this year is that you'll get lots more tricky questions and questions with fractions both in their powers and also out the front as well. So the questions just get a little bit harder in this time. So this is what we've got. F of x equals a times x to the power of n, and a and n are both constants. They don't change. The x is the variable that's changing. So when we get the derivative with respect to x, we multiply by the power, so times by n, and then we minus 1 from the power. And that's the process that we go through every time. We multiply by the power, minus 1 from the power. I should say that this is all instantaneous rate of change, and that's generally what we'd be looking at unless it asks you to do the average rate of change. Now this over on the right hand side, all this means is that you can actually do each individual function separately. So if you've got two functions added together, so for example x squared plus x, you can do the derivative of these two things independently and then just combine the answer at the end. So the derivative of g of x, which is x squared, is just 2x, and the derivative of x is just 1. So we get 2x plus 1. The only other thing I'll mention at this point is if you're ever trying to get the derivative of, say, 2x plus 3, the derivative of that would just be, so if that's f of x, f dash of x would equal just 2, because the 3 is a constant, and any constant it goes down to be 0 anyway. Okay, just a reminder for that. Okay, so just a couple of things to note over here over the left hand side. Just a couple of little tricks or things you need to kind of be aware of. If you have 1 over x squared, or when the power's on the bottom, there's a couple of ways to do this, but the quickest, easiest way is to actually just make the power negative. So I guess bring it up to the top and change the sign to a negative, and then you can just go through, multiply everything by -2, minus 1 from the power, and then carry on from there. Okay. Now a similar sort of thing with this. If you've got the square root of x, then that can just be turned into x to the half, and then if you want to get the derivative of that, multiply everything by a half, minus 1 from the power, and then go from there. And you can rearrange it back in either to this square root signs, or you could just leave it in the fraction form. And then finally, this one is very similar to the previous one. If you've got the cube root of x squared, or if these two numbers were anything really, that would be, I would again change it to x to the power of 2 on 3, so make it a fraction, and then you can multiply everything by 2 on 3, minus 1 from the power, and then go from there. Okay, so you can make things negative powers, or basically eliminate the fraction here. You can turn the powers into fractions and get the final answer from there. Okay, the only other thing that they'll ask you about in 5.3 is how do you say this word? Differentiability. Basically, when can you find the derivative of a graph? And we've sort of looked at this a little bit, but the two key conditions that you need to know about, which we've looked at, is one, that it needs to be a continuous graph. So that doesn't mean that it has to be continuous the entire way along. So, for example, if you have this graph here, and then there, this graph, you can get the derivative for any of the parts where it is continuous. You just can't get the derivative between these 2 points here, okay? And assuming that these are arrows going along there like that. So this graph, you can get the derivative for most of the part, but you just can't get the derivative in between those two bits. So if it's not continuous in that particular part, you can't get the derivative. Similarly with smooth, I'll just alter this one slightly, if I can. There we go. You might have the graph that's continuous like this, but it's actually not smooth. There's a sharp point there. Again, this graph is, you can get the derivative of this graph everywhere except for this point here, because it's not smooth at that particular point. So it doesn't have to be smooth everywhere, but you just, you can only find the derivative where the graph is both continuous and smooth. And one last thing I'll put onto this, that people make mistakes on this every single year, and I don't want you to, so I'm going to write it in red, and that is, you can never get the derivative, very messy writing, sorry, at an endpoint. It doesn't matter whether it's an open circle or a closed circle, you still cannot get the derivative at that particular point. Okay, there's one exception that I might show you later on in the term, but can I just say a general blanket rule, you can never ever find the derivative at an endpoint. Okay, so it's always not included when we're doing the derivative graph or when we're stating the domain of the derivative. Okay, so that's it for 5.3. In the next video, we're going to be looking at the chain rule. So if you've got any questions, please let me know.